These are two geotextiles of equivalent basis weight. On the left is a sample of Type R SF40. Its permeability is 50 litre per square meter per second. On the right is a sample of a needle punch geotextile with a permeability of 100 litre per square meter per second, which is twice the permeability of the Type R. The water should go through the needle punch geotextile twice as fast as through Type R, but the flow rate is so high that the difference can hardly be seen. But in real conditions, do you believe that the needle punch product will perform 2 times better than Type R? Let's see what happens. In both tubes, Type R SF40 was covered with a layer of coarse sand in the left tube, sandy clay in the right tube. 50 centiliter of water is poured into each tube. The flow rate is much higher in the sand layer than in the sandy clay layer, because the sandy clay's permeability is 10,000 times lower than that of the coarse sand. In a system made of materials of different permeabilities, it is the least permeable layer that determines the permeability of the system, and geotextiles are more permeable than soils. There is no difference of performance between a geotextile with a permeability of 50, 100, 1000 or 10,000 litre per square meter per second, because it is the soil which determines the permeability of the whole system. For those who are not convinced yet, 2 new systems were built, with the same coarse sand but a different geotextile in each tube. Type R SF40 and the needle punch geotextile. The flow rate through both systems is essentially the same. Now, do you really believe that a geotextile with a permeability twice that of Type R will perform better?